easy, dead easy. But okay, dead easy, boss. But how you understand? Yeah, we'll wind up this session just 5 minutes. Just bear with me 5 minutes. Okay, spare 5 minutes. Simple. Okay. Now, simple understanding purpose. Yes, boss. Simple understanding purpose. So we tell you one thing. Okay. Uh, swap. Okay, right. Swap. Okay. Afterwards, swap. Afterwards, simple VSZ. Oh, VSZ. Simple. VSZ. Okay. Okay. This is one kind of memory. Think like that. Afterwards, you know very well about cache memory. Cache. Oh, cache memory. Yeah, yeah, cache memory. You know very well about a cache memory, and we know very well about a swap memory. Okay, cache, swap. But we don't know VSZ. Sir, what is VSZ? Okay, yeah, we'll give you more clarity on VSZ. Boss, first of all, we need to understand a swap. Swap is nothing but what? So whenever your server RAM is full, whenever your server RAM is full, to load or to execute, to load your process. That means what? Suppose simple, very, very important, very, very important. So this is your RAM, boss. This is your RAM. Okay. RAM. Okay. This is your disk, either normal hard disk or SSD. Okay. The program is available in this place, P1, P2. Okay. All the programs are available in the disk only. Okay, operating system is the one pick up this program and loading this program into this location. That is what? This is the location which was allocated, created by operating system only. No, operating system first understand the program size and allocating that memory location. That's all. This is the memory location for this program too. That's all. Okay, no, allocation done by operating system only, right? Okay, program number two purpose in a RAM operating system allocate some other place for program number two execution purpose. Program number one execution purpose, one memory location. Program number two execution purpose, one more memory location. Okay, allocated by operating system. That's all. Okay, allocation of the memory done by operating system. Okay. Afterwards, yes, this is a CPU. Oh, again CPU come into picture. The CPU will execute this program immediately. But now, friends, what happens, P3 is a program. Okay, P3 is a program. Okay, operating system is identifying this program and is trying to load this program into this place, but there is no space at all inside a RAM. Assume that assume that there is no space inside a RAM. That means what? A RAM size is full. అమ్మా ర్యామ్ సైజ్ ఫుల్ అయింది. ఓహ్ ప్రోగ్రామ్ నేను ఇవ్వలేనంటే హే హూ ఆర్ యూ. ఓకే, వెరీ వెరీ ఇంపార్టెంట్. సో ఆ టైంలో నువ్వేం చేస్తున్నావు? Simple. Yes, you are fetching your balance. That means what? You are checking your balance. You are transferring money to others. But the program is what? Not able to load in this memory. That time operating system is a very, very clever. That time operating system straight away come to disk. Hey, hard disk, give me your memory because I need a memory, important, urgent. Then this as operating system is take this sum of the memory from the disk and say creating this memory inside this place, just like 1 GB or 2 GB, whatever it is. Okay, afterwards this P3 program will be moving into this place because the RAM is full. That's why the operating system moving this program or data, whatever it is, moving into this place. This place name is what? Memory only. This memory name we can also call as a swap memory. Swap. That is process we can also call as a swapping. That means whenever the RAM is full, the programs or data will be moving from RAM to swap memory for a smooth execution purpose. Otherwise, error. That means what? Performance issue, or downtime. You may get sometime downtime also because no RAM. But how can I execute my programs? How can I load my programs? Very, very difficult task. That's why you know, operating system doing all these activities inside a server. Boss, this picture is available inside a server. Okay, this picture is available inside a server. This is what? Linux server. That's a Linux server. If you understand this concept, you thoroughly understand Docker. Otherwise, you will become zero. Docker is a very, very important, highly demand, highest package skill in the DevOps. Always, always. Docker is a very, very important, high package skill in the DevOps. If you learn only Docker, definitely. But if you want to understand Docker, if you want to become a master in Docker, first of all, you need to understand whatever the concept which we have discussed so far. You master in all these things. Otherwise, you cannot understand Docker concept. You cannot able to crack the interview as a DevOps engineer. Sir, most of the people are learning Docker as a normal and going to interview and they are selecting how, sir? Simple. The requirement is like that and they are taking. Afterwards, the requirement is over, the project, all are over, then they will remove from the company. But you guys are no removing because you are a very much expert resource. That's why no one will remove you in any other company because skilled person is very, very important for every IT organization. They will not remove you. Okay, they will hire you. They will give you a best package for you people. Okay, so swap memory like this. Sir, okay, sir, once the RAM is free, once the RAM is free, again, this will be loading into RAM one more time. This task will be taken care by operating system only. So this concept we can also call as a swapping. This concept is also called as a swapping. That means what? Coming to this place, again going to this place. This is what? Swapping, or we can also call as a paging. Oh, paging or swapping, whatever it is, no problem. Okay, sir. Okay, sir. That is what technique. This is a one kind of technique. This is a swap memory, right, sir? Okay. Sir, what is meant by VSZ, sir? Please tell me. VSZ. So what is the difference between the swap and the VSZ? Tell me, sir. So how you understand the VSZ? But we understood very well about the swap memory, but VSZ. So boss, VSZ means sometimes, sometimes, see, observe carefully. This is your RAM, right. This is your RAM. Yeah. If you type top command, all the fields are related to memories only. That means what? Monitoring the CPU performance, monitoring that is what? Memory performance. All these things comes under top and uptime. Very, very important. If you understand top and uptime command, you will understand the tools, automation tools. There are so many tools available in the market, which we need to understand all these things as a DevOps engineer. Okay, right. Okay, RAM. So now RAM is available. Okay, RAM is available. Okay, boss. But boss, for example, see, RAM is available in this place. Okay, good. Sir, what is VSZ? I'll explain you. VSZ means boss, the total virtual memory used by the particular process. That's all. Okay. What is this, sir? Yes, this is what? P1 process. It is consuming some memory, right? Yes, consuming some memory. But how much memory is consuming by the process one? Yes. How much memory is consuming by the consuming one smart using by the Yes, yes, used by the process 1. This is what? Something called VSZ. It will show you only the virtual memory used by the process. It show you only the virtual memory used by the process. Virtual memory, that's all. Virtual memory used by the process. Okay, that means what? This is also represented by VSZ. That means what? The full form is what? Virtual set size. The full form is virtual set size. That's all. Virtual set size. This is a full form of VSZ. This will give you the entire memory used by a particular process, right? A particular process or a P1 or P2 or P3, whatever it is, right? Sir, what about something called RSA, or that is what? A resident, that is what? Resident. So resident means what? Resident means, see, the physical RAM is also available, boss. Yes, yes. But a resident means it will display you only usage of physical RAM. That's all. Physical RAM usage. Virtual is different, physical is different. So physical purpose, residence. Virtual purpose, VSZ. That's all. Used by or consumed by some other process. Resident is different, VSZ is different. But a resident column is also available and a VSZ column is also available. Resident and VSZ column is also available. Okay, okay. So simple, for a simple understanding purpose, resident, what VSZ, okay, resident, VSZ, both are very, very important. Sir, swap is also very, very important. Let's boss, you purchase a mobile. They are telling that, yes, boss, 8 by 12 GB RAM. Oh, 8, what is the mean by 8 by 12? Initially, it is giving you 8 GB RAM. If the RAM is full, then our memory will be taken from the SSD. That means what? Internal memory. That is called internal memory. In your phone, please check one more time. They are giving you 8 by 12 GB RAM. 8 by 12 GB RAM. Just to open the your phone cover, check this box, and inside this box 8 by 12 GB. 8 means what? 12 GB means what? Something called full memory 12 GB. But only they inserted 8 GB only. Okay, if the 8 GB is full, okay, then inside a SSD, inside a small, something called disk media or hard disk, okay, uh, again 4 GB comes and adding into this memory whenever it is required. That's all. Nothing but what? The people saying that, hey, this is a 12 GB memory, like that, they are saying, no, that is not 12 GB. But internally, the swapping mechanism, the swapping technique is available. That's why they're telling you straight away 12 GB. No, 12 GB means what? It comes 12 GB after some time. But as of now, initially, it is 8 GB only, boss. That's all. It comes from internal memory. Internal means what? Storage, a disk, like that. Okay, this is your phone. Okay, like that. Swap memory is also same. Okay, no problem. But what about cache memories or cache memory? Yes, frequently used programs or data will be stored into this cache memory. That's all. We have already explained, something called cloud front. Okay, right. It is very, very close to a CPU, and it is very, very useful. Cache memory, cache server, cache memory. Yes, we'll explain all these things. Cache memory. That means what? A frequently used data or programs will be storing inside this memory. That means what? No need to come to this place SSD again. This is hard disk. Okay, taking all the programs from the hard disk. Instead of taking all the programs from the hard disk, the frequently programs or data will be available in the cache memory. So whenever the program is required, which is available in the cache memory, is operating system not come to SSD. No, it is taking too much time. That's why operating system going to cache memory. Yes, afterwards this will be, loading into main memory and the execution starts. That's all. This is very, very easy because always operating system coming to SSD and taking the program very, very delay process. That's why operating system need not to come to SSD disk always. Operating system comes to this cache memory and loading the programs into main memory very, very easily. That's all. Cache memory is what? Simple. Okay, right. Okay, this is what cache memory. So we understood cache memory and swap memory, something called a swap memory. Yes, something called VSZ or a resident. What is this? Resident also. Okay, but anyway, main memory is very, very fast, boss, compare than others. So swap memory is also very slow because it comes from the hard disk only. That's all. Okay, try to understand the concept thoroughly. Okay, right. As friends, suppose, sir, can I display resident size and residence usage as well as VSZ usage? Can I display? Yes, you can display the resident as well as VSZ also. Simple. Residence or VSZ also. Simple. Okay, like something called PSO, AO, like that. PSAO, PID, okay, COMM, okay, that means what? NI. Okay. Like that, we can also display swap memory, okay, VSZ, and something called resident, or something called, swap resident, and one more thing is, boss, simple. One more thing is something called a shared memory. Yeah, shared memory is also very, very important. Share the memory. That means what, sir? What is meant by shared memory? What is the purpose of shared memory? Simple, very, very simple memory. Okay, very, very simple understanding. Shared memory means what? Pause. Suppose, see, observe carefully. Simple. This is a memory utilization technique. Shared memory is nothing but what? Memory utilization technique, boss. That's all. So now, yeah, I'll wind up after just 2 minutes. I'll wind up this session. 2 minutes only. 2 minutes, just 2 minutes. Okay. Now this is the RAM, boss. Okay, okay. Now this is a memory space, memory space, memory space, memory space, memory space, memory space. Yes, memory space. Boss, this memory space used by P1 process, P2 process, P3 process, P4 process, P5 process, P6 process, P7 process, P8 process, P9 process, like that. But see, observe carefully, there is some wastage in the memory locations. There is some wastage in the memory locations also. If you do like this, there is some wastage in the memory location. That means what? Each process is having its own location, its own memory space. That is means what? Suppose a process requires something called 40 KB, but this memory allocation size is 60 KB, but 20 KB is waste here now. Oh, this process P4 is utilizing just like 30 KB. That memory location size is what? 100 KB. But how much wastage, boss? 70 KB is wastage now. This is a technique number one. That is what this is scenario number one, right? But as of now, most of the people not using this scenario. So most of the people are using case two. Sir, what is this case two, sir? Very, very important. Case 2, see, same picture, but something called boss. This is very, very important technique. Sir, this is RAM. Yes, this is RAM only. Yeah, yeah, this is RAM only. Inside this RAM, the total memory size is something called 500. KB, let's say. But this 500 KB shared by all the process simultaneously. P1 process can access this memory space, P2 process can access this memory space, and P3 process can access this memory space, and P4 also can access this memory, and P5 also can access memory. Yes, yes, this kind of technique or process we can also call as a sharing. That's all. This is also called as a shared memory. Shared memory. Understand. The shared memory is nothing but this and this multiple processor. That multiple processes can be accessed at the same memory location. This is called shared memory. This is very, very useful, and this will give you the memory, yes, utilization. Yes, yes. But in a first case, oh, we are wasting our memory. Simple. We are wasting our memory because the program is required, 30 KB, but you allocated 50 KB. You allocated 50 KB. How much wastage is, boss? 20 KB is wastage. 20 KB wastage. This is what? A shared memory. Boss, if you understand this thing, definitely you understand Docker containers. That's all. To overcome this process, Docker containers comes into picture. That's all. Okay, okay. Suppose if your program size is P1, process size is something called 30 KB, only 30 KB space will be allocated for this process only. No wastage. That's why most of the people are creating the containers and deploying their applications inside a container only. There is no wastage of memory space. That's all. That's why most of the people are using Docker's containers right now in the world. The famous world, excellent tool is what? Docker, which is used to create a ugly number of containers. Ugly means what? So many number of containers. Like this, the memory utilization technique is implemented inside a Docker containers. That's why most of the people are using Dockers. This is a DevOps concept, not Linux. Sir, Linux DevOps is equal? Yes, yes, 100%. But most of the people don't know this secret. 100%. If you understand 100% thoroughly with Linux, nothing is in DevOps. Oh, nothing. No, nothing is there. Everywhere, everything, every tool running on Linux machines only, and every command is running on Linux, Linux, Linux. Everything. Every software is also installing Linux machines only. That's all. DevOps tools. All the DevOps tools, most of the DevOps tools are free tools, boss. Free tools. Most of the DevOps tools are free. That's why most of the clients are coming to DevOps tools, DevOps process. Simple. But process is very, very excellent process, and they designed like that. Okay, they designed the process is very, very excellent manner, boss. Okay, like that, we use a shared memory. Shared memory is what? This kind of a technique, their kind of utilization we are calling as a shared memory. That is also called as a shared memory. The short form is SHR. Oh, SHR. Yes, VSZ or resident and something swap and everything will